Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Rafi bin Syamni. My metric number is 2022-794089. Okay, today I'm going to give in this video I'm going to give some explanation about our assessment given by Dr. Akim, which is the subject course is MAT455, which is calculus. The assessment given is assessment 2. So let's go to the first task. Okay. The first task given is double integral, which is the reversing order. Okay, given the double integral, which is from 0 to 2 and 4 minus y squared to 4, and the equation is y exponent power of s dy dx. Okay, the first question wants us to plot the region using mathematical application. We use the GeoGebra in this question. But before that, before we want to plot the graph, we should know how the range first. So the range for x is 4 minus y squared until 4, and for y is from 0 until z. Okay, I'm sorry, until 2. Sorry, my bad. Okay, and this is the graph as you can see here. Okay. This is the graph from I use the zebra to plot this graph. Okay, this is the result. Okay. Okay. Next, let's move the next question. Just B. Evaluate the given integral, which is from 0 until 2 and from 4 minus y squared to 4. The given integral is y exponent power of x dy dx. Okay. Now, when we integrate the dx, which is the answer is y exponent x. Okay, then we substitute the value of x to 4 and 4 minus y squared dy. Okay, then the answer for integrate dx is from 0 to 2 y exponent 4 dy minus 0 to 2 y exponent power of 4 minus y squared dy. Okay, next, by using integration by substitution, we let u equal to 4 minus y squared, and du over dy equal to negative 2y, and dy equal to negative du over 2y. Okay. Then we integrate after we are done integrate by substitution. We just integrate the dy. Then we integrate the dy. Okay. Then we integrate the dy. So first y squared times exponent power of 4 over 2, and we integrate just usually because we just don't need the substitute because the equation is easy to convert. Okay, then minus from 0 to 2 integrate y exponent power of u, because we substitute the 4 minus y squared to u. Okay. And negative du over 2y. Okay, then so we got 2 exponent 4 minus from 0 to 2 y exponent u times negative du over 2y. Okay. Then after that we got 2 exponent 4 2 exponent power of 4 plus 1 over 2 from 0 to 2 exponent u du. So because we just simplify, then we just put the value because u. Okay, then we just replace the u to 4 minus y squared into the equation. So the answer that we got is 3 over 2 exponent power of 4 plus 1 over 2. So the answer in decimal is 82.397. Okay. Next question is, okay, let's move to the next question. C. Evaluate the integral by reversing the order of integration. So, we just reverse the order by integration before. So, what we got here is from what we integrate from previous question is from 0 to 4 and square root 4 minus x to 2. So, we just substitute like before, just substitute the value, then we got the from 0 to 4 as x exponent x x exponent x x exponent power of x over 2 dx, okay, because we integrate the dy first. Then we got 1 over 2 from 0 to 4 exponent x power of x from x x exponent power of x dx. Okay, then we use the integration by parts, so we let u equal to x, so du equal to dx. So then we let v equal to exponent power of x, and dv is equal to d exponent x exponent power of x dx. Okay, then we use u dv, so u v minus integrate v du. So then we just substitute the equation before. So we got here is 3 over 2 exponent power of 4 plus 1 over 2. So the answer is in decimal, in value is 82.397. So the answer is same to the previous question, because this is the reversing order, but the value is still same. Okay, now let's move to the next question, which is the task 2, which is the question is the topic for this question is triple integral. So the given solid bounded region by the surface x equal to y squared, and the plane z equal to 0, and x plus z is equal to 1, as in figure below. So this is the question, diagram. Okay, now draw the project of a diagram using mathematical application. We use GeoGebra, and this is the result. Okay, then draw the this is the view for x-axis. Okay, we plot the graph here. Then this is for y-axis view, and the last one is C, is z-axis. This is the view of z-axis. Okay, now hence find the volume of the integral for each projection. Okay, now in this question we must find the x-axis. Okay, in x-axis we use type 1, which is the step 1 is we should know the range first. For x is y squared until 1 minus z, and for range y is from 1 until negative 1, and z is from 0 until 1 minus y squared. So so in this question we must integrate dx first. So we arrange this integral is dx, dz, and dy. So we put the range first. Okay, so we integrate the x. So we just put the value of x here. So so we substitute the value which is 1 minus z 1 minus z minus y squared, so dy dx, dz dy. So we have integrate dx, we done integrate dx, so we integrate the dz. So we integrate dz is equal to z minus z squared over 2 minus 2y squared, minus z y squared, so over dy, dy. So next we integrate the y, we integrate the dz, so we just substitute the value of the dz. So the equation is y power of 4 minus 2y squared plus 1, so minus y power of 4 minus 2y squared plus 1 over 2 dy. So we just do the mathematical problem, solve the mathematical problem like usual. So we got the answer is 1 over 2. We put outside first so we can simplify easily. So equal to 1 over 2. So y power of 4 minus 2y squared plus 1 over dy. So we integrate the y, and last one we integrate the dy because the last one integrate is y. So y power of 5 over 5 minus 2y power of 3 over 3 plus y. So we just put the value inside the value of dy. So the answer is 16 over 30. So we simplify, we got 8 over 15. Okay, next we move to question B. This we need to find the y-axis. So if you want to find y-axis, we use type 2. Just the range is different from previous question. So we need to find the new range. Okay, for x is from 0 until 1 minus z, and for y minus square root x until square root x, and for z from 0 until 1. So we arrange the integral, which is we arrange dy, ds of and dz, because we want integrate, we want to find the y-axis, so we put the dy first. Okay. Then we integrate the y first. So y, so we put the value of dy, which is negative square root x until square root x. So we got there. Then after we integrate the dy, we got 2 square root x dx dz. Then we put aside the 2 value of 2 outside, because we have to simplify the, we want to easy the next move and next step. Okay, so we integrate the dx. So we got x power of 3 over 2 over 3 over 2. So we just put the value of x into this equation, so that after we integrate the dx, we got 1 minus z power of 3 over 2 over dz. So the last one is we integrate the dz. So we got after we integrate the dz and we put the value of z, which is from 0 until 1, so we minus like previous question. So we got the final answer for this y-axis is 8 over 15. Okay. Next, the C question is we must find the z-axis. This is the last question. So we use type 2. So the range is different from this question. So we must find the new range. So range is y squared until 1, for y squared from negative 1 until 1. For z, range for z is from 0 until 1 minus x. Okay. Now we arrange the integrate, which is we put dz, dx, and dy. So because we want to find z-axis, so we put dz first. So we integrate z, we got and substitute the value, we got 1 minus x of dx dy. Then we integrate the dx, and we got and substitute the value from the range given. We find, okay, we got 1 over 2 minus y squared plus y power of 4 over 2 and dy. So the last solution is we integrate the dy and put the value and substitute the value given, that we find the range for y, and the final answer that we got is 8 over 15. So the answer is ABC is same. That answer is same because we just find the volume of this what we call this shape, okay, from this each projection. Okay, the projection. Okay, that's all from me. I think that's all from me. Thank you for watching. Assalamualaikum.